Welcome back to The Innovative Teacher, where we explore practical strategies and ideas to make learning meaningful, engaging, and future-focused. In today's episode, we're diving into one of the most important principles behind immersive learning: pedagogy must lead technology. When schools first consider immersive learning, the conversation almost always starts with hardware. Questions like, how many headsets do we need? Or should every student have a headset? Are common, and on the surface they seem reasonable. After all, one-to-one access seems equitable and forward-thinking. But the reality in classrooms consistently shows that immersive learning does not scale through hardware alone. Giving every student a headset does not automatically improve learning outcomes. In many cases, it can even create new challenges for teachers and learners alike. When immersive technology is deployed without intentional pedagogy, schools often see increased cognitive load for students, fragmented attention for teachers, more complex classroom management, and fewer opportunities for guided discussion or reflection. When all students are fully immersed at once, teaching can become reactive rather than responsive. The technology can start to dominate the lesson rather than support it. The most effective implementations don't begin with devices. They begin with intention. They start with a manageable number of headsets that teachers and students can use confidently. This allows immersive learning to integrate naturally into routines, curriculum structures, and teaching styles. Over time, as confidence grows and expectations become clear, the technology earns trust. Teachers, students, and school leadership all start to see that VR or immersive media is not a distraction, but a tool to enhance learning. A key part of this approach is treating immersive technology as a shared instructional resource, rather than an individual entitlement. Gradual introduction supports collaborative, rotational, and group-based models that are already familiar in effective classroom practice. Pedagogy-first implementation ensures that VR enhances teaching rather than disrupting it. In professional learning at Rainer Digital Labs, this principle underpins every session. Teachers are not asked to adopt a single correct model of VR use. Instead, they are guided to make informed pedagogical choices that fit their context, their students, and their curriculum. There's no one right way to teach with immersive technology. What matters is intentional alignment. Teachers are supported to select approaches that best suit their teaching style, their students' learning needs, the devices and space available, and the curriculum and assessment outcomes. VR is not a replacement for good teaching. It strengthens what teachers already do well. Let's start with autonomous learning. In this model, students engage individually with immersive environments, progressing through structured inquiry, guided exploration, or skill-based challenges at their own pace. The teacher's role shifts but doesn't disappear. They monitor learning, observe outcomes, and scaffold reflection. Autonomous models work particularly well for concept revision, independent practice, skill development, or extension. They do require clear learning intentions, time limits, and exit questions to ensure focus, well-being, and accountability. Next, collaborative learning mirrors strong classroom practice. Students work in pairs or small groups, rotating roles. One learner might be immersed in VR, while others observe, record data, respond to prompts, or prepare questions. Roles rotate so everyone remains actively engaged. This is highly effective for scientific investigations, design and problem-solving challenges, and ethical or scenario-based learning. Structured discussion protocols ensure meaningful contributions from all students, inside and outside the headset. Group-based models with shared reflection take collaboration further. Small groups rotate through VR experiences while others engage with aligned non-VR tasks. Afterward, the teacher leads discussion to connect the virtual experience to learning goals. Reflection prompts are essential here. They move students from what I saw to what I learned, why it matters, and how it connects. This is particularly valuable when introducing new concepts, facilitating whole class inquiry, or linking virtual experiences to real-world applications. Then there's the rotational station model, where immersive learning becomes one station among many. Students move between VR experiences, experiments, collaborative tasks, research, or written synthesis. This approach works well for STEM units, project-based learning, and cross-curricular inquiry. Importantly, the non-VR tasks reinforce what was experienced in VR, ensuring technology enhances learning rather than replacing it. Scaling immersive learning responsibly is another consideration. It doesn't require one-to-one deployment. Shared device sets, rotational timetables, mobile VR trolleys, and targeted year-level rollouts allow schools to integrate immersive learning without compromising equity, safety, or instructional quality. These strategies align immersive learning with existing staffing structures and routines, ensuring consistency across classrooms. Even physical setup is part of pedagogy. Adequate space, clear boundary markers, session lengths, rest breaks, and engagement strategies for non-VR students all influence learning outcomes. When physical design is intentional, lessons run smoothly, teacher confidence increases, and students focus on the learning, not the novelty of the technology. Underlying all of these models is a simple but crucial idea. Pedagogy first, technology second. The number of headsets in a room does not define effective immersive learning. Thoughtful planning, curriculum alignment, and intentional instructional decisions that keep learning at the center do. Autonomous exploration, collaboration, shared reflection, and rotational stations are all valid approaches. Each becomes powerful when aligned with curriculum intent and learner needs. When VR is deployed purely as a novelty or wow factor, it risks being an impressive but ultimately shallow experience. Students may enjoy it, but comprehension and retention are minimal. Teachers may see immersion as exciting but difficult to manage, leading to inconsistent use and declining confidence. By contrast, intentionally designed immersive learning embeds learning objectives, scaffolding, and reflection, so that every experience is meaningful and measurable. Professional learning is a critical part of this. Teachers need to experience immersive learning as learners, not just as operators of hardware. When educators engage themselves, they develop shared language around embodiment, cognitive load, and inquiry. They gain confidence to scaffold student learning, structure reflection, and integrate VR meaningfully. Without this foundation, even the best hardware can be underutilized or misapplied. Another common misconception is that engagement equals learning. While immersive experiences often spark curiosity, excitement alone does not guarantee understanding. Learning occurs when students act, make decisions, observe consequences, and reflect. A VR simulation in a science class is only effective when students manipulate variables, test ideas, and explain their reasoning. Without structured guidance, reflection, and assessment, the experience remains entertainment, not education. Curriculum alignment is also essential. Immersive experiences should be deliberately mapped to outcomes, problem-solving, conceptual understanding, collaboration, and reflection. When integrated properly, VR becomes a predictable and meaningful part of the learning journey. Students understand that immersive experiences are tools for thinking, experimenting, and understanding, not just a break from routine. Over time, intentional pedagogical practice produces tangible benefits. Teacher confidence grows, students demonstrate measurable understanding, and immersive learning becomes a sustainable part of professional practice. Frameworks such as I4M provide structure, ensuring consistency across classrooms and clarity for leadership around learning outcomes and assessment. Leadership support reinforces this approach. School leaders must prioritize pedagogy over devices, fund professional learning, and maintain realistic expectations. When leadership focuses solely on hardware, immersive learning often becomes fragmented, underused, or associated with hype rather than impact. Strong leaders treat VR as a shared instructional resource embedded in thoughtful planning, professional development, and measurable learning goals. Ultimately, the heart of pedagogical foundations is simple. Immersive learning works best when teaching drives technology. Technology is not the lesson. It's the medium through which understanding, reflection, and application happen. Teachers maintain authority, guide inquiry, and assess learning meaningfully. Students explore, collaborate, reflect, and demonstrate understanding. VR becomes not just cool, but a deliberately integrated tool that strengthens pedagogy. When pedagogy leads and technology supports, immersive learning transforms from novelty into a reliable, adaptable, and scalable approach. It aligns with curriculum, supports teacher expertise, engages students actively, and produces observable learning outcomes. For educators implementing immersive learning, the takeaway is clear. Start with pedagogy. Consider classroom needs, curriculum alignment, and student experience. Deploy devices thoughtfully. Build professional confidence. Focus on reflection, decision-making, and measurable evidence. Pedagogical foundations are the backbone of any immersive learning initiative that aims to last, scale, and produce genuine understanding. When this principle is embedded consistently, immersive technology stops being a fun tool and becomes a transformative medium that enhances teaching, learning, and student outcomes across any classroom or learning environment. As we conclude this episode, we've seen that immersive learning is not defined by the number of headsets in a classroom or the latest app on the market. We've learned that pedagogy must lead technology, that thoughtful planning and alignment with curriculum and student needs are essential, and that structured approaches like autonomous, collaborative, and rotational models allow VR to enhance learning rather than dominate it. By keeping learning at the center, providing reflection opportunities, and supporting teachers with professional learning, immersive experiences move from novelty to meaningful, measurable education. In our next episode, we'll continue this journey by exploring building teacher capacity, how educators can develop the confidence, skills, and professional insight to integrate immersive learning effectively, ensuring that both teaching and learning are enriched. Until next time, keep observing, keep reflecting, and keep thinking like an innovative teacher. Once again, thanks for listening.